All right, let's get right into it. If you're building a RAG system, you already know the golden rule. Garbage in, garbage out. The quality of your answers is completely tied to the quality of your data. So today, we're going to talk about that first, crucial, and honestly often overlooked step, document preprocessing. Think of it like this. We're going to take that raw, messy data ore and refine it into pure, retrieval-ready gold. So let me ask you something, and be honest. Is messy data killing your RAG performance? I mean, really think about it. You can have the most powerful model, the most clever prompts, but if you're feeding it junk, noisy, inconsistent text, you're basically fighting with one hand tied behind your back from day one. And look, this isn't some small, nitpicky thing. The numbers don't lie. Getting your pre-processing right can slash your noise-related false positives by 20 to 40%. That is a huge deal. It means your system stops pulling in junk documents and starts giving you the sharp, accurate answers you're actually looking for. So yeah, let's dive in and see how we do it. Okay, so our first stop in the refinery is what I call structural cleaning. This is our first pass, our first big filter. We're going to tackle the most obvious, glaring problems in our documents before we start polishing the details. First up, and you know it sounds almost too simple, but it's white space normalization. And trust me, it's a game changer. We're just talking about fixing all that weird spacing, the random tabs, the extra line breaks, all the stuff that totally trips up the algorithms when they're trying to chunk up your text. I mean, just look at the difference here. The before on the left is a total mess, right? But the after on the right, that's clean, it's consistent, it's something a machine can actually understand and process properly. All we're aiming for is one clean space between words and normal paragraph breaks. Simple, but so effective. All right, next up, we get rid of the boilerplate. You know what I'm talking about? All that repetitive junk text that adds zero value. Stuff like page numbers, headers, footers, copyright notices, you name it. It's just noise. It doesn't help answer a single question, so we've got to get it out of there. And here's a perfect example of the impact. See how we just poof, remove the page 5 of 20 and the confidential stamp? Now the embedding model has no choice but to focus on the actual meat of the content. Remember, every single useless word you get rid of makes the important words shine that much brighter. Okay, so we've handled the big structural stuff. Now it's time to zoom in for some character-level refinements. This is where we start polishing the tiny details that, believe it or not, can cause some really big headaches for retrieval. So if you've ever worked with scanned documents, you know the pain of OCR, optical character recognition. It's amazing technology, but let's be real, it makes a lot of mistakes. It messes up weird character combinations, it gets confused by ligatures. It's just part of the deal. Just take a look at this. The word final has that weird phi ligature. Now, to you and me, that's obviously final, but to a computer, that phi is a totally separate, unique character. It's not an F followed by an I. So by fixing these tiny errors and standardizing things like dashes and quotes, we're making sure every word is represented the exact same way every time. And that is absolutely critical for good embeddings. And this whole idea actually leads to a more, let's say, official process called Unicode normalization. Specifically, we often use a form called NFKC. All it does, really, is take all those characters that look similar to us, like all the different kinds of dashes or quotation marks, and it smushes them down into one single standard version. Because when it comes to this stuff, consistency is everything. Oh, and one last quick one for this section. Hyphenation. You see this all the time. A word like example gets broken at the end of a line. We just need to stitch that back together. It's usually a simple find and replace, but it's super important to make sure the model sees the whole word and gets its full meaning. All right, let's kick things up a notch and talk about handling special formats. This is where we get into the pro-level stuff. We'll look at some tricky document types and maybe even bust a few myths you might have heard. Okay, so what if your source is a web page? Well, then you've got a bunch of HTML to deal with. Your mission, should you choose to accept it, is to get rid of everything that isn't the actual content. We're talking scripts, style sheets, nav bars, footers, all the chrome. A tool like Beautiful Soup is perfect for this. It lets you go in like a surgeon and pull out just the pure text. Now listen up, because this is a huge pro tip. If you've been around NLP for a while, you were probably taught to do things like remove stop words or do stemming and limitation. For modern RAG systems, I'm telling you, do not do that. Seriously. Today's embedding models are way smarter. They actually use the context from little words like is or a, and they totally get the difference between run and running. If you strip that stuff out, you're actually just throwing away valuable information and hurting your performance. So yeah, don't do it. Okay, so we've got all these individual cleaning techniques. What's next? Well, the final step is to put it all together. We need to build an automated pipeline that can take any raw document and, step by step, turn it into that analysis-ready pure gold we've been talking about. But wait, before we give a document the final stamp of approval, there's one last checkpoint: quality scoring. Think of this as your automated bouncer at the door. It's a script that programmatically checks the quality of the cleaned up text to make sure no garbage accidentally slipped through our filters. So how does that work, you ask? It's pretty straightforward, really. You can build a simple scoring system. For example, a chunk of text might lose points if it's super short or if it's full of weird special characters. But it could gain points if it looks like it has well-formed sentences. The idea is to set a minimum score, and if a chunk doesn't make the cut, it doesn't get into your vector database. Simple as that. And here you have it, the whole pipeline, start to finish. And listen, the order here really, really matters. You start small with the character level stuff like encoding in Unicode. Then you fix OCR and hyphenation. Then you go bigger, handling the structure like whitespace and boilerplate. And only at the very end do you score it and filter out the bad stuff. Follow these steps in order. So to make this super practical for you, here's a checklist you can literally take and use right now. Is your white space normalized? Check. Have you gotten rid of all that boilerplate junk? Check. Fixed the OCR errors, scored the quality, filtered the low-quality chunks. If you can tick all these boxes, you are well on your way to way, way better retrieval results. So, as we wrap this up, I want to leave you with a question to take back to your own work. Take a hard look at your data. What's the #1 impurity, the first piece of ore that you're going to refine? Because nailing that first cleanup step can literally change the game for your rack system. Seriously. Thanks for tuning in and happy building.